Back to another video, guys. You on A-Level Maths with me, with Daniel Dawes. Today we will consider polynomials. We'll give definition for polynomial structure, so what it is. You will have a taste what they are in general, and also I'll provide plenty of examples so that you can get the main idea, the main concepts of polynomials. And also we'll go through basic operations that you can perform with polynomials. Okay, so basic operations, I mean just those four basic operations, arithmetic operations that you can find in any mathematics. So this is addition, subtraction, multiplication, and division. So that's why after watching this video, you'll get the idea of what polynomials are and also be able to perform correctly and in systematic way of those operations that I mentioned. Basically, you'll be able to work with polynomials. And first of all, let's give a more general definition for polynomial. So here is you can pause the video, try to read, try to understand, maybe try to write if you have a pen and notes, and it's necessary in our class to have those attributes. So you can read, and after reading, trying to maybe write, and then let's compare with what I'll give to you. Okay. So, polynomial is defined as an expression which is composed of variables, constants, and exponents that are combined using algebraic addition. So what they mean by saying expression composed of variables, constant, and exponents. So that's why I'll write out an expression with a single term and let it be, for example, 4x squared and y cubed. So that's the single term. As you can see, it consists of a number part, which is 4 in this case. It's number part, basically a real number. It's multiplied out by a variable part. So this whole is the variable part. Actually, as you can see, it's represented in the index form. So this is index form, or in other words to say it's exponent. So you know that exponent more typically in maths is represented by some a number raised to the power of x. However, here it's also an exponent, but with the base x raised to the power 2 and base y raised to the power 3. So that's why maybe it's better to say that it's not exponent but variables in index form. Okay, if you have repeating variable, multiply it by itself, so you can use a shortcut using index form. But this is the same as saying exponents in general. Okay, index form or exponents. So they are combined together with the multiplication, but those words combined using algebraic addition means that there are several terms which compose of number part and variable part, and they combine using algebraic addition. So that means if you have another term, let's say 3x and y cubed and probably z, for example, just let it be another variable. So you can combine those two terms, the first term and the second term, by combining it using algebraic addition. So what they mean? They mean that you can add them up. So 4x squared y cubed plus, for example, 3x y cubed z. If you had, for example, negative 3 as the number before the second term, no matter, you still can use addition. So, and that's going to be algebraic addition, because indeed, if you expand those brackets, you'll get 4x squared y cubed minus 3x y cubed z. But nonetheless, you still have algebraic addition, because you can come back to addition and saying that coefficient, this number part, is just negative. So that's why the word algebraic addition means that you can every time come back to addition. All right. So right now we have a polynomial expression that consists of two terms. So this polynomial consists of two terms and several variables in it. So each part represented here consists of number part and variable part as an exponent. So I hope you get it, and we can also consider polynomial as the function. So in this case, the function of several variables x, y, and z itself. Okay, if you say that this function is simply represented by this difference or algebraic sum if you use -3 as the coefficient. Sometimes instead of constant before variable parts, you can say that this is coefficient 4 and this coefficient -3. No matter how we call it, but you need to understand that this part is the number part which is multiplied by variable part. Okay, so that's polynomial. If you want to consider polynomial of just one single variable, because normally in the course you will go through functions of one variable, no problem. So you can set up polynomial. Let's say we have the first term. Let's consider. Let us set up polynomial made up of three terms. The first term will have the highest power. It's going to be 3x to the power 6. The second term would be -2x, and the last term is going to be just a constant +1. As you understand, this is also the third term, but it doesn't have any variable in it, right? It's just a constant. Okay, we might set up that that's going to be a variable but raised to the power 0, because any number raised to the power 0 is going to be 1 except for x not equal to 0, right? So x should be 0 in this case. Okay, so that's still going to be 1. As you understand, here's the function is a polynomial which has some maximum power of 6, and then the power is just decreasing. However, here is a significant drop from power 6 to the power of 1, right? And it means that according to standard form how to write polynomials, several powers or several terms are skipped. Okay, but we'll talk a bit later about this. So right now you need to understand that generally polynomial is an expression which represented by several terms, and each term is just multiplication of number part and variable part, and variable part is represented by exponents or can be written in index form. So variables inside the letter part might be very different, like x, y, z, s in this case. Okay, hope you got it. Hope you got what polynomial is and are, and that's why we go to more specific words here. So we can find monomial, binomial, and trinomial. So what it means that, for example, in monomial structure, polynomial should have one term. For example, just 3x and y squared. Okay, that's going to be monomial, and this is still polynomial structure. However, it has just one single term. So binomial, two terms. Remember binomial expansion, a plus or minus b to some power n. This is what exactly binomial looks like, so it should have two terms. But after expansion, it will have much more, definitely. So related to polynomial structure, two terms, let's write them out like x, for example, -3x cubed. So that's the first term, that's the second term, okay? So trinomials, three terms. All right, let's put three terms in a row, -2x squared. So in this case, as you can see, depending on how many terms you'll have, that's define specific name. Up to 3 terms here, you can see that. But after if your polynomial has more than 3 terms, so you just have a general name, polynomial. Okay, So that's this where it comes from. Alright, so it's right time to consider polynomial as a function of one variable, and in most of the case you'll be working either with this sort of functions in terms of you'll be sketching the graph, you'll be just trying maybe to solve when polynomial is equal to 0, this sort of equations, polynomial equations, and you most of the case you'll be working with one variable. However, before, as we discussed before, so we had several variables. Okay, so in general, let's consider a polynomial as a function of one variable. Because this is the general form how to write polynomial, as you can see here, I'll just interpret what's written here. So you can find the maximum power x to the power n. So that will define the order of the polynomial. So you need to search for the maximum power, the term with the maximum power. So you're looking for exponents, okay? You're looking for the powers. And in this general case, n will have the maximum power, okay? That's going to be the order of the polynomial. Order of polynomial. The order sometimes called as the degree of the polynomial, okay? So the maximum power. And for all other terms, as you understand, the power is dropping every time, okay? So this, what is called coefficients, a1, a0, a2, an for the general nth term, okay? So that's why those coefficients are those constants or number parts. So this is the general case how we can denote. And as you can see, the power that your variable raised up correspond to a number of coefficients. So index, let's say index of the coefficients. Because, okay, I'll give you examples. And for like well-known polynomials, actually you already know them. But in general case, so in order not to enumerate or list all the letters of the alphabet, of the English alphabet, so mathematicians decided to change the index form. So you write in before nth term, index n's of the coefficient before the variable part, and raised to the power n. Okay, that's going to be a leading coefficient because it stays before the maximum power n. Okay, so that's why in this case you write in raising order, but you can also, and maybe more standard way is to start from the maximum power from the leading term and then decrease power every time by 1. So that's more general writings. Okay, and plus then you skip and add up the pre-last term, actually a1x imaginary to the power 1, and plus the last coefficient a0. Okay, so that's the general writing how you can put the polynomial of the order n or degree n of one variable. So I forgot to mention that the powers that you can see here, so the powers here, here, and everywhere, 1 here and x to the power 0, you can write in this way, they should be integers. So when I give definition here, so exponents need to have integer power. If it's fractional one, it's not a polynomial. For example, I'm going to write that it's going to be, for example, p from x, let it be 3x to the power 1 over 2. So it's not a polynomial because the power is not integer. And why it's not? Because actually you'll come back to inverse function, as you remember, for normal function, quadratic function x squared. So right now this is inverse function, and this doesn't give this is in contradiction how you define polynomial. Polynomial should have integer power, and this is very significant. So this is the example of a function of one variable. So if you say that, okay, we want to have polynomial of power 0, what you need to do, you just need to plug into general formula n equals to 0. That's going to be 0 degree polynomial, and if you plug in, so you say, okay, it's going to be 0 and x to the power 0, which is 1, and all other terms will disappear, so you just can erase the rest part and stay with the only leading coefficients. It's going to be a1, and x to the power 0 will give you 1, okay? So that's why it's just a constant. If you say that we going to have n equals 1, so a polynomial of the first degree, or the first order, so we'll get just two terms, a1 x to the power 1, and the next term up to 0, because the minimum power for a polynomial must be 0, okay? So that's why you just plug n equals 1 into the next part, into the next term, and you'll get a0 and x to the power 0, which is 1. So the general form is going to be a1x plus a0. And this is, as you can see, a linear expression right now. Just recognize, if you remember how the equation of straight line looks like, it looks like mx plus c, right? So x, you can match mx with the a1x, and constant a0 with c, it's also constant, no matter which letters, which coefficients you use in here. So that's the same expression, which is linear one, okay? More examples. For example, let's take, I just quiz, okay, and put quadratic one, so p2 from x. You again, in general formula, you put n equals 2, and you'll get a2 x squared, that's the leading coefficient, plus a1x, and finally plus a0, okay? So in this case, 3 terms, so that's why it's trinomial. It's trinomial with 3 terms in a row, and this is quadratic expression, or quadratic function, and so on, okay? You can basically extend this onto more and more degrees, okay? And that's examples of polynomials of different degrees or different orders. And here are more definite examples. For example, for 0 you can just take one term. For degree 1 you can get 3x plus 1. Of course that might be a monomial, for example 3x, that's also the case. So for the power 2, instead of writing 4x squared plus 1x plus 1, you can take just simply 4x squared and plus 1. So this is binomial, and simply this coefficient is 0 instead of 1. So you can you actually skipped the middle term. So because according to standard form, if you want to write all the terms, you need to write 4x squared plus, instead of 1 you put 0 times x, that's the middle term, which is absent in our case, and plus 1. So this still polynomial of power 2, except for I just changed coefficient of 1 onto 0. And now, as you understand, the result of this multiplication is just 0. You'll get 4x squared plus 1, and so on, okay? So that's power 3, that's power 4, that's the degree of polynomials. And however, in other particular examples, you might have several terms skipped. For example, you can skip that term and that term, and you'll be given 6x4 plus 2x plus 1. This is trinomial. However, still, the maximum power is 4, so that's why it's still p4 from x. However, several terms are skipped. So that's normally, might be the case, and that's why you need to understand that it's still polynomial of order 4 with several coefficients to be 0, okay? You need to be able actually to understand which coefficients are 0 in this case. Okay, according, if you compare with the general way of, for example, writing a polynomial with a4x4 plus a3x cubed plus a2x squared plus a1x plus a0. So you understand that in our case, if I provide this particular example, we have a3 equals to a2 and equals to 0. So those two coefficients are 0 if you compare with general standard form of the polynomial. Okay, so I hope you got those basics. I hope you understand how polynomial looks like, and in the next video we will discuss how to perform basic operations. I'll give you several ways how to approach to how to add, how to subtract, how to multiply, and how to divide. So probably I'll give you separate videos in order you'll have a separate list of skills, and I just set up a unique video for each operations. However, I'll combine addition and subtraction because in just the main essence it's basically the same. So hope you like that. That was Daniel Dallas with Maths, and see you in the next video. Goodbye.